and high frequency figure of merit. So how can you say that my MOSFET is going to work very well at very high frequencies? So what parameter we account for? So for that, there are two high frequency figures of merit available for MOSFET. One is going to be omega T and omega max. Omega T and omega max both are frequencies. So they are the frequencies at which the current and power gain are unity. So in omega T, it is called as threshold frequency where the current gain is unity. So the output current by input current equal to 1. And omega max is the frequency where the power gain is unity, output power equal to input power. So in that case, you can find out these two frequencies and say that till that frequency I can operate my MOSFET without any issue. So these are going to be the boundary conditions for operating your MOSFET. Larger the value of omega T and omega max, your device is very good for operating at very high frequencies. So after analyzing MOSFET, they found the relation between output current and input current. You know, output current is ID, drain current, input current is IN. Approximately, you have the expression GM by omega into CGS plus CGD. So this is current gain. So if I equate this expression to 1, I can get the value for omega t. I have to replace omega by omega t, equate this current ratio to 1. That is what we are doing. So when you equate this current ratio to 1, Gm by omega t into CGS plus CGD equal to 1, or you get omega t equal to Gm by CGS plus CGD. So this is the frequency at which the current gain is going to be unity. So you see, it depends on the trans conductance of MOSFET and the capacitance CGS and CGD. CGS is between gate and source. CGD is between gate and drain. So all these capacitance will determine the highest frequency at which the current gain becomes equal to unity. Same way, if we equate the power gain to unity, we get this frequency of operation omega max is approximately equal to half of square root of omega t by Rg into CGD. And omega max depends on omega t. Rg is the gate resistance. Okay, so omega max is derived from omega t expression. So internally, omega t expression also has CGS and CGD. So the omega max also depends on CGS and CGD. So these two things you should be very clear on how to analyze the performance of MOSFET at high frequency using the two frequencies omega t and omega max. Omega t is the largest frequency at which the current gain of the device becomes unity, and omega max is the largest frequency of the device at which the power gain becomes unity. So it is very clear that omega max depends on gate resistance. So it is more comprehensive than omega t. Omega t just depends on capacitance, but omega max, you see, it is inversely proportional to the gate resistance. You know, generally the resistance of gate is very high, so I can say omega, it limits the value of omega max. So because judicious layout can reduce MOS the resistance to smaller values, omega max can be considerably larger than omega t for many MOSFET. But by properly fabricating the devices, I can reduce the value of gate resistance Rg. So if I can do that, my omega max value will be large. If omega max value is large, uh, omega t also can be made larger. Okay, so that is what is the conclusion we have. How to maximize the value of these two frequencies. The output capacitance has no effect on omega max, but it can be turned or tuned out with the pure inductance and therefore does not limit the amount of power delivered to your load. So in the both the expression, you see the output capacitance does not play a role. It is all the capacitance between the electrodes or between the regions, right? So that is a very good sign to say that maximum power can be delivered to the load without the effect on the capacitances. And you can measure these frequencies just like how we carry out experiments for frequency response of an amplifier. So vary the frequency, measure the power, measure the current or measure the voltage. From voltage, you can measure the power and you can find where the power is dropping, plot the frequency response graph. So where the power gain is becoming 0 dB or where the current gain is becoming 0 dB, draw a line that corresponds to omega t and omega max. So very measuring these two frequencies is very much similar to how we perform the frequency response of any common emitter amplifier.